Classroom.
Good
Yeah,
afternoon.
yeah, good afternoon. Shall I start?
Good afternoon, sir.
Yeah, good afternoon. Shall I start the class?
Yes.
Okay.
Yes, sir.
Yeah. May I know what is the last problem covered? Yeah. Okay. Yeah, the last one I covered is something. One block is on horizontal surface, other one is hanging vertically. Correct.
Yes, sir.
Yes, sir.
Then today let us continue some concepts. Concepts you want or problem?
Problem.
Problem.
The
It's a
problem.
both. Both.
Okay. Okay. You write one more problem. Actually, I want to start concepts. Okay. If anyone wants, sorry, you are saying let us write one problem. Okay. Write down one problem. They given like this. Say one block is given, something 10 kg. Above this, something is placed. Yeah, this is also a good question. Some standard question. 6 kg. Mu is 1 by 2. See, how many blocks I am placing one over the other?
2.
2. Yeah. How much mass you have to place on this 10 kg so that this system does not move? Means, what's your target? You have to find this m value so that the system does not move. Means the system is at rest. Write down the question. Find for what value of m. Find for what value of small m. For what value of small m the system ready to move. The system ready to move. Tell me how to solve this problem.
60
Yesterday,
Newton
this
equal to
one block we placed on
frictional
surface.
force.
Now 2 blocks are started.
60 Newton
Yeah.
is equal to frictional force.
60 Newton is equal to frictional force. That's it. Very good. Here, see, what is the tension? T. How much this is balanced? 60 Newton.
60 Newton.
And here, this one is T. This T is balanced by what? Limiting friction. This T is balanced by limiting friction because this system is ready to move. It's not moving. It's ready to move. So, when it's ready to move, T balanced by?
Sir, 2 kg.
Yeah. What is this? 60. FL. Mu N. 60. What is mu? 1 by 2. This N nothing but mg. M nothing but m plus 10 into g. Is it okay?
Yes, sir.
And here, what is n? Above, how many masses are there? M and 10. Target is to find out m. So, 60 into 2, m plus 10 into 10. 12 m plus 10. How much the mass you have to place? How much the mass you have to place? Tell me.
2 kg.
2 kg.
If you place 2 kg mass, above 10 kg, then system ready to move, it will not move. Completed?
Yes,
sir.
sir.
Yeah.
Yes, sir.
Now see, let me find how much the minimum force we need to apply on a block so that the block is ready to move. Generally, if any block is placed on horizontal surface, if you place any block on horizontal surface, then we need to apply some minimum force so that the block is ready to move. If the force is maximum, what about the block? If the force is something increases, then the block will move with certain acceleration. That acceleration we calculated in the last class. Now here, what I am going to find is, so write down as a concept and note. So write down the minimum force required. Minimum force needed to pull the block. The minimum force needed to pull the block so that the block is ready to slide. So that the block is ready to slide. So that the block is ready to slide. The minimum force needed to pull the block so that the block has to ready to move, ready to slide. It's not moving, ready to. So let us suppose, let me place a block on horizontal surface like this. A block on horizontal surface whose mass is m, weight of the block mg, normal reaction force is upwards. I want to apply pulling. Okay. So this is the pulling force. I am applying with an angle something theta. I am applying some pulling force. This is the pulling force. How much the minimum force is needed? What is the least force required to pull this block on a table such that the block ready to move? It's not moving. So we need maybe 1 Newton, 2 Newton. That amount we needed. Let us see. So this F is resolved into how many components now?
2 components.
Components.
Resolve it now.
Vertical.
F cos theta. And one more component is upward.
F sin.
So if F is downwards, F sin theta downwards. Now what is this component?
F sin theta.
Sin theta. F cos theta, F sin theta. Tell me from this diagram, n plus F sin theta balanced by n plus F sin theta balanced by mg. Then what is normal reaction force? mg minus F sin theta. mg minus F sin theta. Keep in mind this one. I got normal reaction force. By using that normal reaction force, we can expect whether it is easy to pull or easy to push. Okay, we'll see that also. Is it okay up to now?
Yes, sir.
Yeah. If it is ready to move, what type of frictional force will act backside?
Yes.
Limit.
Ready to move.
Limiting
If it is
friction.
moving, Fk. Ready to move. Fl, maximum value of static friction.
Limiting friction.
Yeah, limiting friction. Very good. For suppose if F cos theta is less than Fl, then what happened to the body? Then the body will be static or not? The body will be static. It is at rest only. If F cos theta is less than Fl, then what about the body? Will the body will move?
No, sir.
No, sir.
No. If F cos theta greater than Fl, yes, it will move with certain acceleration. That acceleration we got in the last class. Okay. Because in the last class I applied force horizontally. Now I am changing the direction of the force. Last class, I applied a force horizontally, then I got A formula. Now here the direction of the force is changes. So in place of F, you write F cos theta, that's it. If F cos theta is equivalent to Fl, then tell me, then body,
Ready to move.
very good. Ready to slide, ready to move. It's not moving, ready to move. If it is greater, it will move with acceleration. That acceleration also we can find. That acceleration also we can find easily. Let us use this condition. F cos theta is equal to Fl. So F cos theta, Fl nothing but mu n.
Yes, sir.
Yeah, Fl nothing but mu n. F cos theta, mu, what is n? Mg minus F sin theta. See, this entire right side value is frictional force. Entire right side value is frictional force. Mu mg minus F sin theta. Target is to find out what is this F. This F. You simplify the equation. So left side is F cos theta. Right side just multiply mu mg minus mu F sin theta. Take this mu F sin theta left side. F cos theta plus mu F sin theta, which is equivalent to mu mg. Got it? What is the target? What is the target? F. Shall I take F common here?
Yes, sir.
Because F is available. Then take F common. Cos theta plus mu sin theta is equal to what? Shall I write one more step downside? Is it visible? If I write downside one more step, can anyone?
Yes, sir.
Is it visible downside? Is it okay?
Yes, sir.
Mu mg divided by cos theta plus this is the minimum force required to pull the body so that the body ready to move. Okay. No need to worry. These many steps are there like this. No need to worry. Just you feel the concept. Okay. See, this is the formula. Mu mg by cos theta plus mu sin theta is the minimum amount of force to pull the body so that the body ready to move. Okay. This amount of force is needed. Okay. For suppose in a problem they given something angle of friction is given. They are not given this theta value. They given some angle of friction, and they are asking to find the minimum amount of force. By giving the theta, if they ask to find minimum force, we can use this formula. But they are not given angle. They given angle of friction. Pi is given. Anyone remember tan pi? Tan pi value how much? Tan pi value.
Fs by n.
Fs by n. Okay, done. That is nothing but mu.
Mu S, sir.
Yeah, mu s. Mu s nothing but shall I write mu l?
Yes, sir.
Yeah, ready to move
Yes,
is
sir.
mu yes mu. Otherwise, let us write mu. That's it. Meaning is clear. What is this mu? Is it a kinetic friction?
No, sir.
This mu is a
Limiting
kinetic
friction.
friction. It's a limiting. Okay, no need to mention. That is mu is enough. For suppose, anyhow, we know tan pi as mu. Let us see one more extension step. F is equals to mu mg cos theta plus shall I write this mu as a tan pi? This mu shall I write as a tan pi?
Yes, sir.
Tan pi shall I write as sin pi by cos pi? Got it? Mu I
Yes,
written
sir.
tan pi. Tan pi becomes sin pi by cos pi. Sin theta. Take LCM. So what is downside? Cos theta cos pi plus sin pi Sin theta divided by cos phi. Shall I take that cos phi into the numerator? Is it clear? This is one more format, one more form of minimum pulling force. Mu
Sir, we
and
can
V
write
cos phi.
denominator as cos of theta minus phi, no, sir?
Yeah, that's what next I want to write. Yeah, F is equals to mu mg cos phi. Shall I write this as cos of theta minus phi? Cos A minus B, one more form. Based on the given option, you need to extend the calculation. Okay, calculations are your duty especially. Based on the given options, you can extend the steps. Right now, I got this step. Of course, this option is, for suppose this option is not there. Okay, they asked the conceptual question. See, in a NEET exam, you know, some of them are conceptual questions. Out of 45, nearly 8 to 10, sometimes they may ask conceptual formulas. They will ask only the formulas. Okay, you remember only this formula, but option is something. In option, this is not there, this second also not there, that also not there. One more option is there. Means you have to extend this minimum force. Let us see how to extend this one more step. Mu mg cos phi by cos theta minus phi. We need to get force minimum. When force is minimum, tell me. For F to be minimum, which value is maximum? For F to be minimum, tell me which value is
Excuse me,
maximum?
sir.
Yeah.
Sir, the board is blurred, sir.
Now, I'm not changing anything here actually.
Still blurred, sir.
Still blurred.
Yes, sir.
Maybe the signal problem. Check it once. Signal is
Once again, please explain, sir, how you can take that mu as a tan theta. Sir, actually, I
mu
didn't get.
as a tan pi.
Yes, sir, that only.
Tell me why it is a tan pi as a mu. What is angle of friction formula? Yesterday you attended. Tan pi is equal to mu. Last class derivation. Tan pi value mu we derived in the last class. Check it.
Yes, sir.
Okay. Tan pi as mu. What is pi? What is the name of pi? Tell me. What is the name of pi?
Angle of friction.
Yeah, angle of friction. Tan pi we derived in the previous sessions. Check your notes if you attend. Means if you attend the class. Okay. Is it okay for F to be minimum? Tell me what is cos theta minus phi value? I want to get minimum value.
1.
Then whatever denominator value, that should be
1.
maximum. Maximum value of cos theta is 1.
Sir, theta
Yes,
equals
sir.
to 90.
Yeah, no. How, theta is
Theta minus
90
phi is equal to 90.
when sin is there. When sin is there, theta is 90. For cos,
0 degrees.
0 degrees. So this should be 1 nothing but theta. This should be what? For F to be minimum, this must be maximum. When it is maximum? If theta minus phi is equal to 0, correct? Cos 0 value. Cos 0 value 1.
1, sir.
1.
You go for the other value, it is less than 1 because this is cos, not sin. Any confusion here? Theta minus pi as 0. Then what is theta and pi? Theta becomes pi. So what is the minimum force? F minimum is equals to mu mg cos phi divided by next values are less than 1. Not possible. Highest value of cos is 1 only. Theta and pi are equal. So this is the minimum force. What is the minimum force now? F minimum, which is equivalent to mu mg cos phi. Any other changes? Can I write this mu as a one more sin pi by cos pi?
Yes, sir, we
Any
can write.
confusion? Any confusion this at this region? If any confusion is there, to get the minimum value, you just equate these angles. That's it. To get the minimum value, you
Board is
equal
there, sir.
which one?
The board is there.
Board is blurred means what I want to tell me, no? It's because sometimes signal is not clear, I think. Okay. Now also blurred.
Yes, sir. Lead.
Yes, sir.
Yes, sir.
Go ahead. Wait. Huh? We'll see. Still also blurred. Huh?
Yes, sir. Your voice is also breaking.
Oh, it's not my problem actually. Let us see. Don't worry. Sir, something signal is not clear. I think. This one.
The mic sounds.
Mic sound. Then they're telling board is not clear and voice also not clear.
So ask everyone, sir. Suppose a few students are not getting the signal.
Yeah. Can anyone other can please respond other
Blue is
students?
blur. Yes, sir. Blue.
Sir,
Yeah.
blur, sir.
It's blurred.
Yes, sir.
Yes. Yes,
So
sir.
now,
Sir,
now
voice
it's
also
clear,
breaking,
sir.
sir.
Now
Yes, sir.
it's
Sir,
Voice
it's
also
clear.
breaking.
Voice little breaking.
Clear,
sir.
stucking.
To be online in 5 minutes.
Okay. Yeah. Yeah. Please stay online for 5 minutes. We'll get you in touch. Just stay online for 5 minutes. Yeah, students, is it clear?
Yes, sir.
Arpita, Bhargav, MS. Can anyone please respond it? Murli, L, Swami, Chinmayi, Bharadwaj.
Yes, sir. It's clear.
Very good. Shall I continue? Vinay, Tanisha, Jayan, Shruti. Is it clear right now?
Yes, sir.
Okay, let me continue. Okay, what is the minimum value I'm getting here now? Is the board is visible right now?
Yes, sir.
Okay,
Yes,
better
sir.
you write it and write F minimum is how much? F minimum I got mu mg cos pi. If you want, you can extend one more step also. If you write mu as a sin pi by cos pi cancelled. What is the final answer? One more answer.
Sin mg.
Yeah, mg sin pi. mg sin pi. mg sin pi. Got it? One more formula is possible. So let me write here. If you write mu as a sin pi by cos pi, sin pi cos pi mg cos pi, then cos pi cancelled. What is the one more answer now? F minimum is mg sin pi. If you want one more also, we can write it. What is tan pi formula? Mu. What is tan pi? Tan pi is mu.
Yes, sir.
Is pi. Tan pi is mu. This is one. What is this? Mu square plus one. Tan pi is mu. Mu by 1, tan pi, opposite by adjacent. What is the hypotenuse? Root of mu square plus 1.
Yes, sir.
Shall we write sin pi as a one more conversion? See this
Mu
way of extension. Are you following the extension? Mg sin pi we have mg sin pi. Shall I write sin pi as a? Tell me from the triangle.
mu by
Mu by root of
plus.
mu square plus 1.
Very good. Mu by root of what? See, try to remember all these different model formulas. Mu mg by root of mu square plus 1. So these are the minimum forces. 1 type, 2, 3, 4, 5. Based on the given option, you can go through the formula. Anyone? Otherwise, let me give one problem to get some confidence. Right, everyone? And see, here I am getting frictional force. See, this is the frictional force. I am getting negative sign. Keep in mind, frictional force I am getting negative. Got it? Mg minus, I am getting negative frictional force. Frictional force is less in case of pulling. Observe my point. Frictional force is less in case of pulling. Keep in point in mind. Let me try pushing. Written everyone?
Yes, sir.
Yeah, write the heading minimum force needed to push the block on a horizontal surface. Push the block on horizontal surface. Will you try this derivation? Will you extend the same steps like a previous one? Let me show the diagram. By using diagram, you try to extend the steps. Find out the minimum value of the force. See, this is the block. Mass is m. Weight of the block is mg. Normal reaction is upward. And let me push the block like this with the force F. This is theta. I'll give the diagram. You try to extend the steps. If I extend this, if this is theta, what is this? Resolve the F into two components. Resolve the F into two components. What is this component? Tell me.
F cos theta.
Yeah, tell me in which direction F sin theta will act? Upward or downward?
Downward.
Downward. Yeah, the F is there here, so F sin theta will be downward. F sin theta. What is the normal reaction? What is the normal?
mg sin theta.
mg plus mg plus F sin theta.
F sin theta.
Now, for the body ready to slide, F cos theta balanced by.
FL.
Will you extend the steps? For the body ready to slide, F cos theta balanced by FL. F cos theta, FL is nothing but mu n. Observe the steps, mu cos theta, F cos theta, mu, what is n? Tell me, mg plus, what is n? mg plus F sin theta. Observe the frictional force here. What is the frictional force here? Positive I am getting. What is the frictional force in the previous case?
Negative.
Yeah,
Negative.
mg minus F sin theta I got in previous case. Now I got mg plus F sin theta. So tell me, in which case the frictional force is more? In case of pushing, the frictional force is more, or pulling, the frictional force is more?
Pushing.
Yeah. In case of pushing the block, the frictional force is more. In case of pulling the block, what is the frictional force? You got negative.
Negative.
That means less or more?
Less.
Less. Okay. So here the frictional force is more. In a previous concept, in a previous case, frictional force is less. Then tell me, if any block is there on a floor, then will you pull the block or will you push the block? Means easy to pull or easy to push? Tell me. Pulling is easy or pushing is easy?
Pulling is
Pulling. Why pulling is easy? Tell me. Because
friction.
less friction. Because in case of pulling, the frictional force is less. In case of pushing,
Friction force is more.
Friction for increase.
frictional force more. So that is tough. So if any roller is placed on a table, if a lawn roller or a roller, any spherical body, any cylinder, tell me, cylinder is easy to pull, means pulling is easy or pushing is easy? Cylinder. Pulling is easy. Why? Because in case of pulling, frictional force is less. In case of pushing, frictional force is more. So if any body is placed on horizontal surface, then pulling the body is easier than pushing. Keep in mind. If you place any body on a horizontal floor, then pulling the body is easy than pushing. Pulling the body, which is easy than pushing, because in case of pulling, frictional force is less. In case of pushing, frictional force, anyhow, it is got already more, maximum. Okay, let us continue the derivation now. Will you continue the steps? Will you continue? Chinmay Bharadwaj, respond anyone? Chirantan, V. Will you continue the next steps?
Yes, sir.
Continue. Tanishayan, respond. Harshita Gowda. Yeah, continue the steps. F cos theta which is equivalent to mu mg plus mu f sin theta. Okay, take this mu f sin theta left side. F cos theta minus mu f sin theta is equal to mu mg. Take f common. Cos theta mu sin theta is equal to mu mg. So f is equal to mu mg by, previously we got plus, now we got minus, that's it. Cos theta minus mu sin theta. This is one form. If you want, we can extend it. Shall we substitute mu as a tan pi? So you will get negative. Mu as a tan pi means negative you will get. See, what is the next step? Mu replaced by sin pi by cos pi and minus pi. Next you take this cos pi to here, cos theta cos pi minus sin theta sin pi, or sin pi sin theta. And this is what? What is that? Cos of a plus b, cos of a minus b. Cos a cos b minus sin a sin b, cos of a plus b. And this is one more formula. Continue the steps. First, suppose if theta is equal to 0, then tell me what is f minimum value? Mu mg cos pi by theta 0, cos pi. Then what is the minimum force? Mu mg. Otherwise, minimum force is mg tan pi. What is mu? What is mu? See the way.
Sir, F minimum at cos of theta plus pi is equal to 1, no, sir?
Yeah, theta plus pi is 1, okay. But theta plus pi is 1 means you will get some complicated numbers, no? Because we don't know two values.
Sir, we will get theta is equal to minus pi.
Theta is equals to 1 minus pi you will get. 1 minus pi means again complicated or not? Just you think it. Earlier,
Sir,
theta,
no, sir. We will get theta is equal to minus pi only.
theta is equals to, if you write
Minus pi.
if you write 0, you will get minus pi. Got it?
Sir, no, sir. Cos 0 is equal to 1, no, sir.
Yeah. Cos 0 is 1.
Then theta is equal to minus pi, sir.
Yeah, you will get one more. Correct. Theta is equal to minus pi. You can substitute it, no problem.
Sir,
Theta
we
is
will get F minimum is equal to mu mg cos pi, sir.
mu mg. Yeah,
Cos pi.
that is also not a problem because theta is equal to minus pi. If I substitute theta is equal to minus pi, then again how much you will get? Mu mg. At the end, you are
No,
getting
sir. Mu mg cos pi I will get, sir.
mu mg.
Cos pi.
What about the denominator value?
Sir, it will become 1 because it will become theta minus pi is equal to 0. Cos 0 is equal to 1.
Okay, tell me if theta plus pi is equals to, tell me how much? 0, na?
Sir, 0. Yes, sir.
Okay, carry on. Theta is equals to, correct?
Yes, sir.
Theta is equals to minus pi. If you write theta is equal to minus pi, okay, no problem. That, yeah, condition correct. Theta is equals to minus pi plus pi. Then cos, tell me how much? You are getting mg, sorry, mu mg,
Mu mg cos phi, sir.
mu mg cos phi. Okay, carry on. Because the condition is correct. Because my doubt, okay, my word, okay, you are, according to you, theta you are getting minus pi. What's my question is the sum of two numbers will give 0? What is the previous one? Theta minus pi is equal to 0. Yes, correct. Because difference between two numbers is 0 is possible. Is sum of two numbers, sum of two angles will give 0? Can anyone?
Sir, sir,
Yeah,
if
tell me.
one is in clockwise, another one is anti-clockwise, then it will give 0, no, sir.
No, 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 no. Not sum is, sum cannot be 0. Product, you know, sum of roots, product of roots. Sum, how can you write as a 0? Tell me. That's why I am waiting for that.
You add -2 and +2, sir, then we'll get 0.
How it is possible? No, no, no. It's not clear. Not correct. That's why sum is there. Now we cannot write this as a 0. Earlier, theta minus pi is there. Then what I written? Difference between two numbers will give what? Generally, you think in a positive way. If you think negative, now everything is wrong in physics. That is the effect of physics now. Okay, if I tell clockwise, if you want to move anti-clockwise, means no one will impossible to understand the physics now. That's why the way you follow it, just you check it. Difference between the numbers, yes, it is 0. Sum of two numbers, how can you get 0? Will you
Sir,
agree?
one measured in clockwise direction, other measured in anti-clockwise direction, then 0, no, sir.
Okay, values clockwise. Okay, you are telling clockwise, anti-clockwise. Clockwise one side, anti-clockwise you are going to take negative or not?
Yes, sir.
You are saying 0, no?
Yes, sir.
Okay, carry on, but that's not correct here because we are applying only one force. I'm not applying two forces.
Sir, to get to force minimum means the denominator should be maximum, no, sir.
Correct, that is correct. But how these sum is equivalent to 0? That's my question. You are telling clockwise, anti-clockwise. Clockwise, anti-clockwise means how many forces I am applying? How many forces I need? One or two? If two forces are there, okay, I will take
Sir,
your time.
1.
No, I am applying only one force. I want to get only one minimum force. If I take two forces, one is in this direction, one more is in this direction, then I can agree your words. Right now, I am taking single force. I cannot agree your words. Hmm?
Sir, we have one force that making an angle theta and we have another force that resultant that is making an angle phi, no, sir.
Where is another force? Okay.
Sir, that resultant force, sir, that frictional and Newton, Allah.
Okay.
Normal, that is
Very
making phi, no, sir. Phi.
you try no, you try and send to me. I'll check whether the conditions are correct or not. Okay. Let me continue. Shall I continue? Because
Okay, sir.
otherwise one more concept now. Hmm?
Yes,
Shall
sir.
I? Yeah, very good. So F is equals to mu mg. May I know your name? May I know
Sir,
who is
Puneet.
that? Ah, yeah. Punita.
Sir, Puneet.
Punit.
Yes, sir.
Punit. Yeah, yeah. Very good. Carry on. No problem. Think in that way, no problem. That definitely you will enjoy the physics. Yeah. What is the answer now? F is equal to mu mg. Let us try one more concept because I need to finish one more concept now. Take this. Write down one more concept.
Written, sir.
Yeah, I'll wait. Yeah, take this. I'll find how much the coefficient of friction needed so that a child is placed on a table such that the child is ready to slide. It's not sliding, ready to slide. Let me give the concept correctly now. So that formulas will help in solving the so many variety of problems. First, you take this thing, and for the next concept, you write a small heading. Chain on a table. So the same concept will come in next chapter in working energy power. There we are going to learn all means what distance the chain is moving and what is the work done by the chain, whether that work done is in the form of potential energy or kinetic energy. Everything we are going to learn in the next chapters. Right now only friction I am going to find out. Okay. So let us suppose they given a chain whose mass is m, whose length is something capital L, that is placed on the table. How they placed is they placed some part of the chain on the table and remaining part is hanging from the edge of the table. So let me repeat. They given a chain. Okay. They given a chain like this. This is the cable and these are the chain links. Okay, layers, chain links. Some part of the length of the chain is hanging like this. Total length of the chain is how much I am taking now? Total length is L. Total length of the chain is capital L. Total mass is capital M. This length of hanging part is L. Length of the hanging part is how much? Small l. Let us suppose small l is equals to 1 by nth of capital L. If it is half part, what is small l? If it is half part, what is small l? Small l is equal to, yeah,
L by 2.
small l is equal to capital L by 2. If it is half part, if it is 1/3 part, small l is equal to L by 3.
Yes, sir.
Yeah.
Yes, sir.
Okay. And see, let us suppose small m is the mass of this part only, hanging part. Small m is the mass of only hanging part. Then what is the weight of this hanging part? Shall I write? This weight of the hanging part is something mg by n, 1 by nth of marginal weight. This is 1 by nth of marginal weight. If it is half part, mg by 2. If it is half part, mg by 2. If it is 1/3 part, mg by 3. And what is the weight of this part? Weight of this part is mg minus 1 by nth of mg, because 1 by nth of mg is here. If everything is on here, this is 0, only mg. Are you following this weight? Is it okay this one? Mg minus 1 by n mg.
Yes, sir.
Explain, sir.
Is it clear? Mg minus 1 by mg, 1 by n into mg.
So once
Because
Sir,
please
again,
explain.
explain, sir.
yeah, mg in this how much part is hanging? 1 by nth part is hanging. 1 by nth part is hanging. Okay. Now the normal reaction is balanced by how much amount of force? Mg minus how much the normal reaction? Tell me. Normal
mg
reaction.
minus mg by n.
Ah, very good. So here the chain is ready to move in this direction. This is the force actually. This force is balanced by frictional force or not. Because of this force, this chain is ready to
Yes,
move.
sir.
It's not moving, it's ready to move. When the body ready to move, this force is balanced by this one. As the chain ready to move, as the chain ready to slide on a table, then frictional force is balanced by what? 1 by nth of mg. Will you agree this? Will you agree? Frictional force is balanced by 1 by nth part of mg. This is the force. Because of this force, the body ready to come down. Will you agree this step?
Yes, sir.
Respond now. Shall I continue the next step? What is FL? Mu n.
mu n.
Yeah. Is it okay, mu n?
Yes, sir.
1 by n mg. Mu n. Mu. What is n? mg minus 1 by n mg into 1 by n mg. So strike of mg. Mu into 1 minus 1 by n.
Minus 1 by.
Yeah. Anything wrong? So 1 by n. N cancel out. What is mu value? So this is one relation. between mu and n. What actually n? N is the number. If it is half part, n value 2. Don't write it as a 1 by 2. If it is half part is hanging, n value 2. 1/3 is hanging, n value 3. 1 by n is 1 by 3, like that. Okay, half part is hanging. 1 by 2 is equal to 1 by n is equal to 2. Got it? So I got mu value. Okay, what actually this mu nothing but mu L. Okay, what is that mu? Is it a static, kinetic, rolling, limiting?
Limiting.
Limiting.
Limiting. Okay,
Limiting.
mu L, mu L, mu L. Okay, mu S if they given also not a problem. Mu S also okay, we can agree. Static also okay, because maximum value of static, nothing but limiting. Okay, if mu L is not given, if they given mu S, you can accept it. That's not a problem. So mu L is equals to 1 by n minus 1. N minus 1 is equal to 1 by mu L. So n is equals to 1 by mu L plus 1. N is equals to 1 plus mu L by mu L. What is n? What is n? See, L is equal to 1 by n. L. What is n? L by n. Take this n. Capital L by small l. Correct. Shall I substitute n as a capital L by small l? 1 plus mu L by mu L. And this can be written as small l by capital L. We can write it as mu L by 1 plus mu L. So this we can call it as L by L, we can call it as maximum fractional length. Fractional length of chain. Maximum fractional length of the chain is how much? Small l by capital L, which is equivalent to mu L by 1 plus mu. For suppose mu is given 1 by 2, we can find the fractional change in length, fractional length. If they ask you to find percentages, just multiply 100 on both sides. So 1 by 2 divided by 1 plus 1 by 2, you will get the answer. So feel the concept and try to apply this concept to solve problems from any type of book. Not only our material, you can apply concepts for any type of book, your wish. Okay. First, you try to enjoy the concept. If you enjoy the concept, automatically we can solve the problem from any level. Okay. Right now, I got maximum fractional length and mu L. If n is given, we can find this. If this is given, we can find n. N is the number. If they ask the ratio, we can find the ratio. Small l by capital L, fractional length. Okay. What about tomorrow? So remaining topics I'll continue in the next sessions. Okay. Let me stop now today. Thank you.
Yes, sir.
Thank you, sir. Bye, sir.
Sir.
Thank you, sir. Bye, sir.
Yeah, note down this one. I'm going to close this. Note down.